Hello, this is Kelly Hansan with a case study presentation on the winter storm event December the 13th, 2016 in Indianapolis. On Tuesday, December 13th, 2016, the Indianapolis area had a winter storm system that brought 3.9 inches of snow. It was in a short time period. Typically, the month of December for Indianapolis receives a total of 6.9 inches of snow. On average, December 13th has around 3/10 of an inch of snow, and this was the first snow of the season with only trace amounts leading up to this event. It moved through around daybreak and tapered off by mid-afternoon. There was an upper wave that was over Missouri. Moisture was being advected from the Gulf of Mexico from a surface trough, and snow became widespread throughout the morning as the forcing of the upper wave moved over the area. Now, the almanac for Indianapolis, KIND, the normal high is 39 degrees Fahrenheit and the normal low is 25 degrees Fahrenheit, and this is for December the 13th, and temperatures only climbed to 32 degrees Fahrenheit, and the low temperature, which fell right before midnight, was down to 11 degrees Fahrenheit on December 13th. Now, here is the snow map of December 13th, 2016 from the National Weather Service. There was a swath of snow that fell across central Indiana, with the heaviest swath along the I-70 corridor, which is right through here. And you can see those pockets of heavier snowfall with 3 to 4 inches, 4 to 6 inches, where the heavier snow was being depicted. And of course, KIND reported 3.9 inches of snow. The snow fell from 13Z until 19Z on December 13th, 2016. There was only a hazardous weather outlooks and special weather statements. There were never any winter weather advisories issued for this event. Now, here's the SKU-T log P for KILX in central Illinois. It was recorded at 12Z on December 13, 2016. Now, this is the closest balloon sounding to Indianapolis. Now, there was warm air advection at 900 millibars, but the entire sounding is below freezing. The air temperature of this sounding was near zero at the surface until we get to about 900 millibars, but you can see that warm pocket of air on that day. Now, this is the SKU-T sounding from KILX at 0Z December 14, 2016. Much colder air has arrived with the surface temperature at 20 degrees Fahrenheit. The dew point is dried out to 4 degrees Fahrenheit, and it's obvious that the cold front has moved through this location. See this much colder air. Here's that 0Z isotherm, and that Arctic air really pushed that cold air in at the surface. Now, this is a time lapse of the NAM 500 millibar heights and vorticity analysis, and it shows that a trough was poised just to move over central Indiana around 12Z on Tuesday, December the 14th. Now, analyzing this area at 12Z on December the 13th, there's a stronger area of vorticity over Nebraska on this 500 millibar NAM forecast. You can see that right here. Now, this chart is the 500 millibar height and absolute vorticity for 0Z December 14th, 2016. The shortwave is now centered over central Indiana with the vortmax of 21 times 10 meters per second. Right there. And now moving on to the buff kit run of the NAM 4 kilometer 13Z. This shows that the cold air was cold enough for just snow, and the elevated warm air was forecast to be minus 1.3 degrees Celsius, around 900 millibars. So there would be no melting at this area. You can see a little bit of that warm air. It's not much, and again, it's still not very close to that zero isotherm. Moving on to the 14Z run. This is the still the 14Z buff kit of NAM 4K. And the air should be saturated enough at this point, as the dew point is close to the air temperature, that it should be falling as snow, and buff kit is showing that snow should be developing as well. And when we compare this to the wrap at 14Z, It's interesting to look at this because it's also showing that the air is saturated, but it's also showing an elevated warm layer with the temperature warming to 0.3 degrees Celsius. So it's actually above zero here, but it's a very small elevated level, and if any melting occurred, it would just be very small. And the rule of thumb is that the elevated melting layer needs to be 1 degree to 3 degree or 4 degrees Celsius. So likely this would be an only snow event. And again, the wrap is also showing that it's snow as well. Moving on to the 17Z of the NAM again, this sounding is showing that the air is saturated and snow is likely falling as heavily snow. By 5Z, December 14th, 2016, the Arctic front has arrived and the drier air is arriving. The air temperature should tumble to minus 8.4 degrees Celsius. So again, the balloon sounding from Illinois also showing that Arctic air, but this is showing in the forecast that it's going to happen in Indianapolis as well. So very sharply colder air moving in. Looking at the overview of the NAM 4K buff kit, it's showing that the relative humidity is also high, running minus 10 degrees Celsius and higher. And this is during the good snow growth and omega time frame of high possibility of seeing that snow growth from 12Z until 18Z. And you can see that right here through our forecast period, 12Z to 18Z. The upward vertical velocity with the omega very high and good snow growth region as well. And there is that strong upward velocity, and the liquid equivalent was 1900ths of an inch, which was likely being reported very low from the ASOS. But the snowflakes likely grew through riming, and the crystals fell through the dendritic growth zone and then became in contact with the supercooled water droplets as they fell the long way between 0 degrees Celsius to minus degrees Celsius, then down to the surface. Now here's the surface observations at 13.0Z. This is the overview, again, of the relative humidity running minus 10 degrees Celsius. Here are the observations at 13 UTC. And this was on December 13th. KIND was just starting to get snow. It was considered light snow at the time. And then by 16Z, December 13th, 2016, the snow had increased in intensity at KIND. Now this is the 20Z, and it's showing that snow is still falling at KIND, but there is a clearing to the northwest where the Arctic front is located. And you can see that here where Lafayette is showing that air moving in from the northwest, allowing that drier air to arrive with the dew point dropping to 17 degrees. Now here's a time lapse of the radar. So this is the next rad radar from December 13th, 125Z through December 13th, 2355Z. And just moving along into some of these next rad images, this is showing the leading edge of the system making its way around 6:55 on December the 13th. Then a pocket of heavier snow was setting up to the southwest in central Indiana at 8:55 on December 13th. By 12:55Z, the snow became more widespread around central Indiana and over Indianapolis. And then moving on to 14:25, although it's not as heavy as earlier, it's still showing that snow is falling, and it is tapering off from west to east, and this was at 18:25 UTC. And here's another time lapse, and this is starting at the top of our forecast area at the 300 millibar level. We'll go on through these where we're looking at the 0Z, December 13th, 300 millibars. Now, the upper air is very cold, running minus 46 degrees Celsius in Indiana. You can see that here. Very strong winds aloft. And then moving on to the 12Z, December 13th, the air temperature has dropped to minus 50 degrees Celsius. Moving on to the 0Z observation on December 14th, 2016, there are strong winds aloft with divergence over central Indiana. The Arctic air remains in place as the polar jet moves over the plains, Midwest, and Northeast, and the jet streak is over Wyoming and Nebraska on the left side of the jet, and another streak out to the east in Pennsylvania, right through here, and then right through here. As we move on here, this is the observation at 12Z on December the 14th. The weak jet streak is over Ohio with a strong winds aloft with this jet streak moving on out of here. So it likely did provide some lift as it moved over central Indiana. All right, here's the time lapse. This is at 500 millibars, and this observation is from December 13th, 0Z through December 14th, 12Z. And moving on to the 0Z observations here on December the 13th, there are strong winds at the 500 millibar level with cold temperatures running minus 22 degrees Celsius. The height over central Indiana is 560 millibars, and that is cold air for snow development. You can see that 560 line. And this is 12Z, again for December the 13th. The air temperature has dropped to minus 24 degrees Celsius. The winds aren't as strong with the 547 millibar to the north of central Indiana, and dew points are in the upper minus 20 degrees Celsius. Again, staying with the 500 millibar observations at 0Z on December the 14th, the air temperature is now back down to minus 25 degrees Celsius, and the 547 millibar line is over central Indiana. You can see that. And as the system was exiting the area, here are the observations at the 500 millibar on December the 14th at 12Z. The dew points have lowered into the upper 30s below zero, and the air temperature is running minus 30 degrees Celsius with warm air south of Indiana, again showing that sharp polar jet stream and how drastic that air temperature change is. Okay, here is the time lapse of observations of 700 millibars, and this is from 0Z December the 13th through 12Z, December 14th. The 700 millibar represents the upper low in Canada. The moisture is low. And this is, again, the 0Z. Moving on to 12Z, we have the trough has shifted at this time frame. It is, we're starting to see a little warm air advection observed at 700 millibars. It's also showing a low dew point depression, depicting moisture in the atmosphere. The air temperature was minus 10 degrees Celsius. The dew point was minus 12, right there. Moving on to the 700 millibar 0Z, still showing a small amount of warm air advection with the short wave. And here's 850 millibar time lapse here. Again, this is from 0Z December 13th through 12Z December 14th. This observation 0Z December 13th is showing that there is perpendicular isotherms with height contours, and that's mainly over northern Indiana. You can see that here with the isotherms and the isobars perpendicular with each other, depicting that we could see a little bit of lift through that area. There's also a large dew point depression. Now, here's the observation of the 850 millibar at 12Z on December the 13th. The isobars and pressure heights are running parallel on this one, and there is a small dew point depression. The air temperature is 1 degree below 0 Celsius, and the dew point is minus 9 degrees Celsius. Here are the observations at 850 0Z on December 14th. This is showing that there's good divergence over Indiana. The isobars are perpendicular with the isotherms, and there's good moisture too. And the air temperature is at minus 5 degrees Celsius, the dew point minus 6. So a very small dew point depression in that area. And again, those isotherms and isobars running parallel with each other for that divergence. Okay, moving on to satellite NextRad of the surface observations. You can see that Arctic cold front pushing across the area, moving in, a lot of clouds overhead, and then the front moved through, allowing that cold Arctic air to arrive. And taking a look at the observations here, this was at 11:03 Z. You can start to see the leading edge of the rain pushing in. At 13 Z on December the 13th, the observation at KIND, we have 32 degrees for the air temperature and 30 degrees for the dew point. Precipitation is falling as snow, and the cold front is still to the northwest, draped across central Illinois. The winds are out of the northeast around 5 knots. With the frontogenesis, there's likely banding of snow during this time frame. Moving through 16Z, the front now making its way into Indianapolis, kind of lingers here at 19Z and then moves on out. And taking a look here, this is the 24-hour precipitation accumulation. This ends on December the 14th, 2016 at 12Z, and it's showing that KIND likely had 2 inches of liquid precipitation from this storm event. Now remember, the ASOS recorded 0.19 of an inch of liquid, which is such a huge difference, which we learned in lecture that there's likely, it's likely depicting it way lower than what actually happened, which messes with the snow ratios, which I believe are around 10-1 with this event. Now the wind started out of the southeast, and that was less than 1 meter per second at 12Z. They shifted then out of the south between 1 and 4 meters per second, and the wind eventually shifted out of the west-northwest at 1 to 4 meters per second by 18Z. This is the meteogram of 0Z on December the 13th through 23Z. Snow started to fall at KIND at 14Z. Visibility fell to 1 mile, and the winds were increasing. Moderate snow started to fall at 15Z, and then visibilities dropped down to less than 1 mile through 18Z. It became foggy by 19Z, and visibility improved. The snow depth was 4 inches, and the liquid precipitation, according to this meteogram, was 1,907 inch. Temperatures were in the upper 20s and low 30s while the snow was falling. In conclusion, the vorticity, upward vertical velocity, and Arctic cold front ramped up the snow accumulation on December the 13th, 2016. Moisture was being ejected from the Gulf. Prior and during the event, the banding of the snow, especially from 14Z through 17Z, allowed for snow to accumulate quickly. Snowfall rates were around 1 inch an hour, especially in the heaviest bands. As an early season event, many motorists were caught off guard, and a winter weather advisory might have been very helpful with this event. I'm Kelly Hansan. Thank you so much.